For number 57 here, we've got a pretty nice looking limit. The limit as x goes to infinity, and then it's a square root and a square root. So one thing you can do at times is use an estimate. So for example, if x is going to infinity, this will be infinity squared, which is infinity, plus 2, that doesn't really count for much. So I could approximate and say the top is approximately like having the square root of x squared, because the plus 2 doesn't count for that much. And the same here with this plus 1. So the bottom I could approximate by saying that's about this much. And then this would be an x, and that would be an x, which cancel. So what's left is 1 over the square root of 2. That's my estimate for the answer. Now I need to actually show my work. So this one is of the form infinity divided by infinity, which means that we could use L'Hopital's rule. So take the derivative on the top. So I'll make one big fraction bar for this fraction. Now take the derivative on the top, and because that's a square root, its derivative is going to be 1 over 2 times that square root. And then do the chain rule. The derivative of the inside is a 2x. Now for the derivative of the denominator, again, it's going to be 1 over 2 times that square root. And then take the derivative of the inside, which is going to be a 4x. So this did not really simplify matters, because we still have the square roots. Now they're in the denominator instead of the numerator. And if you then divide these two fractions, that means invert this one, which is going to put the square root on top and this square root on the bottom. So basically all it did is had them change places. So that's telling me that this is probably not the way to do it. So try something else. So here's the official. That was strike 1, but I'm going to hit it out of the ballpark with number 2. So the thing is, if those square roots weren't there, that sure would be helpful. So what I'm going to do is say, so let y be the function that is the square root divided by the square root and then to eliminate those square roots, square both sides. So it's going to be that y squared is equal to just an x squared plus 2 over a 2x squared plus 1. Then take the limit as x goes to infinity. So then we could use L'Hopital's rule. And this is going to be much simpler now that the square roots are gone. The derivative on the top is going to be 2x. The derivative on the bottom is going to be 4x. And then it's still the limit as x goes to infinity. And this is still y squared equals. Now as you can see over here, the x's are going to cancel, and 2/4 reduces to be 1/2. And since this was still y squared equals, the last thing to do is take square root of both sides. On the top, the square root of 1 is 1. And on the bottom, the square root of 2 is the square root of 2. So my estimate over here seems that it was correct.